Hello, this is part of the FLOW project where we explore fluid mechanics aspects of the flows that we encounter in the lab during the experiments, numerical simulations, and also in nature. And today I am processing the astrophoto, the narrowband image of IC 1396. It's the elephant trunk nebula. I've already pre-processed and calibrated the mono images of the sulfur 2, hydrogen alpha, and oxygen 3 emissions and combined them in a color Hubble palette that's oxygen mapped to a blue channel, sulfur to red, and hydrogen to green. And the image is still linear at this stage, meaning that its dynamic range has not been stretched for enhancement of contrast, etc. This is the best point to correct for the blur introduced by the optics and the light passing through the atmosphere. So this process is called deconvolution, and in simple terms it basically reverses some of the blurring introduced by telescope optics and the atmosphere. So the reconstructing the object as it looks like in high fidelity. So this is not the same as traditional sharpening in photography, which increases local contrast by exaggerating the edges. Instead, deconvolution mathematically models how light from a single point spreads and then estimates how to undo that spreading. Here is the difference. Notice that the fine structures in the nebula become crisper, but without adding artifacts after the deconvolution has been applied. This is important to apply this process while the image is still linear, because stretching later changes pixel relationships, and the deconvolution model needs those details proportional to the intensities to work accurately. So what you are seeing here is just an auto-stretched preview using the screen transfer function. It's kind of a temporary stretch that lets us inspect the detail in the data without permanently altering it. So the real color calibration and tone mapping will come later, but already you can see the structure of the gas clouds emerging. So this is the technical note for today. Post-processing is a large part of flow visualization and data analysis, and both in the engineering applications, in the experiments in the lab, and CFD, computational data visualization, and also in photography of the flows on a very large scale, like the cosmic nebula, like this one. So stay tuned for more details as this image evolves, and see you later.